Today we will look at the process by which scientists perform their experiments. The main method that scientists use to study the world around them is the scientific method. I'm sure you've heard about it in other science classes in the past. But in general, it consists of about 5 steps from an initial observation through a conclusion and the development of a potential theory. The scientific method is applied to both controlled studies and field studies. A controlled study usually occurs in the lab and a field study out in the environment. The first step in the scientific method is to make an observation. We know that nature is decently orderly and measurable. We can then use that knowledge as well as our 5 senses and instrumentation that we may have in our laboratories to make an observation. So if we're out in the ocean and we see a number of fish, we can look at these animals here and make some observations about them. They're all in the ocean, so they're all marine. Maybe they're all fish. Maybe they all have gills. Let's see if we can test those hypotheses. First off, we're going to use those statements about those fish to generate our hypothesis. The hypothesis is not an educated guess. It is something that we've observed. We've been out in the ocean, we've seen a number of animals, and we've decided to test who and what they are. We didn't just guess, okay? It is a testable statement that we can use our brains, our inductive and our deductive reasoning to generate a prediction. So, after we generate these predictions, we then have to do experiments. Experiments must be designed very carefully. We will have a control group that has had nothing done to it or is a sample population. Then we'll have a data group, which is the people or the animals or the chemicals or anything on which we are doing the experiments. Okay? We then compare typically the data group to the control group. Now, not every study has to have a control group, but many will have a control group. But experiments are the things that scientists actually do in the lab to test their hypothesis. And so our hypotheses here, in general, are that all fish have gills, maybe, or that all marine organisms, anything that we find in the ocean, will have gills. And then, in addition, we may have more specific hypotheses, such as, whales have gills. Let's test each of those hypotheses. Or, once we do that, so we take a bunch of fish, we keep catching fish, we have a great time on the water, and we look at each one to determine if it has gills or not. However, you should note that after doing that experiment, we then draw our conclusion. The conclusion is a statement as to whether or not our hypothesis is accepted or rejected. Scientists are very leery and do not say that they have proved something. Scientific proof is not something that really exists. No hypothesis can be proven with absolute certainty. So we take our data, we analyze our data, and then we draw a conclusion as to whether or not we can accept or reject our hypothesis. Many times this will result in us having to do additional experiments because we find something else, especially if our hypothesis is rejected. We might need to make a new hypothesis. So in our fish example, this is a simple example, but after we look and see if all fish have gills or if whales have gills, we can catch the fish, look at them, see if they have gills. That's our testing phase and our experimental phase. And then come up with our observations. Well, if we catch the blowfish and some of these other fish, we note that they all have gills. However, we do not ever see any gills on a whale. So, we can conclude then that our hypothesis is accepted, that all fish have gills, but the hypothesis that whales have gills is rejected. So here, in a nutshell, is what happens in the scientific method and the 5 main steps of the scientific method. We make an observation. We might use data that we've collected in the past, or something that we've seen in nature. We make that observation. We might look at other people's data to see if they have made the same observation that we have. And then from that, we develop a hypothesis. We take all that information and we formulate a testable statement. We take that testable statement and we perform experiments to support or refute that testable statement. We do experiments, we make more observations, we do all kinds of things in the lab. And after we feel like we have done enough work, then we can take all of that data, we analyze the data, maybe graph the data or take pictures, all kinds of ways that we can take the data, and use that data to develop a conclusion. That conclusion will either support or cause us to support or reject our hypothesis. If we reject our hypothesis, we can go back and make a new hypothesis, as is shown by this arrow going backwards. If our hypothesis is accepted, however, this might lead us to the development of a scientific theory. If it supports a new theory or something new, then that often can be published in scientific literature. The scientific method is applied to a number of different types of studies. The two types that we will focus on are a controlled study and a field study. A controlled study is done in a lab, and a field study would be done in the environment. A controlled study has a set of strictly regulated experiments or observations. You're going to make changes to one variable and not change the other variable. The thing that is being tested is the independent variable, and the thing that responds to what you're changing is the dependent variable. So we change an experimental variable or an independent variable, and we get a response from the responding variable or the dependent variable. This is the thing that we will analyze and often graph in an XY graph, X on the bottom and Y on the vertical. These experiments are extremely controlled and always have a negative and a positive control. Finally, there are field studies. In field studies, you go out into the environment and observe something in nature. For example, a biologist might investigate the migratory and mating patterns of birds, and they would do this while out hiking or out in the field making some kind of measurement. I hope that has given you some idea about this process of science.